Welcome to the session on estimation of earthwork quantities. Now in this chapter or in this session, we'll try to learn about the estimation of quantity of earthwork for the embankment or for the quantities for the cutting in the canals or for the foundations, trenches in the foundation like this. Now volume will be always calculated by measuring the length, breadth and depth of the section. And to compute this, we have got the various general methods are there, like the cross section, where most of the estimation quantities of the earthwork will be estimated by cross section method. You got another method called spot levels, where it can be used for major works, a large quantity of works, and for contour lines. The first one is usually adopted universally. The contour line methods will be used roughly to calculate the volume of water stored in the reservoir or water that is accumulated in the ponds. We can make use of the contour lines. We'll study about these methods in the next session. In this session, we'll be more concentrating on method of estimating by cross sections. Here, in this session, we'll be dealing with cross sections having no transverse slope. There is no slope on the sideways. Sideways, we are going to keep it flat, as you observe here. There is no slope here, and on this we are going to estimate the quantities. This is the transverse slope which is kept constant, flat. On an inclined area, that is on an hilly area, we'll calculate in the next session. Calculation of the quantities for the hilly areas we'll try to understand in the next session. Now this what I showed, it was for the embankment. Now we are looking into the cutting portion, which is trapezoidal in shape. We can estimate the quantity of earthwork for this one by considering the cross section of the canal as trapezium. Whether it is embankment or in cutting, the majority of the cross section will be trapezium in shape. So this is we call it as a formation width. This is the depth of cutting. It varies at different sections. According to that, we can calculate the areas of the different sections and the volume between the first and the last section. Now let us try to understand that with respect to the embankment and as well as with respect to the cutting. Here this is for a road embankment, estimate of earthwork for the road embankment. The top width is called as the formation width. This is the depth of earth to be filled up. These are the side slopes of the bank. Will be always measured in terms of horizontal is to vertical slope, vertical slope. But here for our calculation, we are going to always take the vertical slope to be 1. If this is 1, then horizontal slope h will be taken equal to s for the calculation purpose. I'll just give you an example. If this is 2:1, then s is equal to 2. If this is 1.5:1, then slope s is equal to 1.5. If this is 3:2, then you make this vertical equal to 1, get the value of horizontal slope, that is 3/2, which is equal to 1.5, then the slope will be equal to 1.5. S is taken as 1.5 in our calculation. It is not to be taken as 3. I'll show you all those things in the examples. So whether it is embankment or cutting, the trapezium area formula will remain the same. As I said earlier, this is the formation width, and here this will be the formation width. So this embankment and cutting will constitute of a square or a rectangle in the mid zone, and two triangles on the sides. Same way here also in the cutting. We got the rectangular portion or a square portion in the middle, two side portions. So area of a trapezoid is nothing but area of the rectangular portion plus area, two sides, the area of the triangular portion. This is the area of the two triangular portion. So let us see that, how to calculate. The cross-sectional area is equal to area of the rectangular portion, whether it is embankment or cutting, plus 2 times the areas of the triangles on the sides, the two triangular portion. So we know the area of a rectangle, it is B into D. Area of triangle is half into base unit height multiplied by 2 sides. Therefore, it comes out to be BD plus ST square. This is a formula I am going to use it throughout the session. So this area, if it is multiplied by the length, then you will get the volume. So volume or quantity of earthwork is equal to BD plus ST square into the distance between the two sections under consideration. That is L. There are various methods to calculate the volume of earthwork. Now we are going to learn about the 3 methods. We will try to solve the problems by the 3 methods in this session as well as in the coming session. So I got the mid-sectional area method, mean sectional area method, which is also called as trapezoidal method or average end area method. And the third one is the Priss model formula, also called as Simpson's 1/3 rule formula. We'll try to understand the formulas that are used in each one of the method and how to calculate the volume. Now you are seeing a typical isometric view of an embankment, or I can go with the cutting. Both the formulas that are used are same here. Now this is the embankment top width called as formation width B, side slope of the bank S is to 1. The distance between the two sections is L. So in this mid-sectional area, we're going to get the depths D1 and D2 at the two sections. Find out the mean depth of that, dm, that is D1 plus D2 by 2. That's the mean depth. Find out the area of that section, mid area section, we call it as AM. It's given by BDM plus SDM square. So we're going to find out the area of the midsection after calculating mean depth. And this is adopted in the midsection area method. Multiply this quantity with the length between the two sections, you'll get the volume, the quantity. Next one is the same method, but for the multiple section. You got two more number of sections, more than 2 sections. We're going to take the average of the first one and the second one, middle here, find out the area of this, multiply the distance between them. So we'll see that how to write it in the tabular form. Now this is the tabular form we are going to have. Chain edge or the station. These are the chain edges or the stations. The depths at the different sections. D1, D2, D3 like this we are going to enter. The mean depth means the depth of D1 and D2 average we should take and enter it in the mean depth column here. Take the average of D2 and D3, enter it in the mean depth column. Then portion this one, you know it very well. It is BD, is the formula for the central portion or a rectangular square portion. It is BDM, this depth you are going to multiply. The sides SDM square. Get the total area, multiply by the distance between the sections. Sometimes we designate it as L, sometimes we designate it as capital D. There's no problem in designation. Use the form, multiply that with that for each area, enter it either in cutting or filling. So we'll come to know whether it is cutting or filling from the given problem. We'll try to understand those things while solving the problems. The second one is the mean sectional area method or a trapezoidal method also called as average end area method. So in this method, we are going to take the depths d1, d2, but areas will be calculated for the each one section. So that is, for the depth first section d1, we are going to get the area a1 equal to bd1 plus sd1 square. Similarly, get the area for the second section for the depth d2. Get the area, that is bd2 plus sd2 square. Then get the mean of that one is a1 plus a2. The mean area will be a1 plus a2 divided by 2. In the previous section, we had taken d1 plus d2 as dm. For that, we calculated the am. Now here for the each section, we are going to get the areas, and for that, we are going to get the mean cross-section area. Multiply by the distance between the two sections, you are going to get the volume of earthwork. If it is a multiple section, calculate the areas of the each sections. The distance between them is d. It is called as intervals. That is distance between the two sections, successive sections. It's given by the formula d into the average of the first and the last section areas, a1 and a2 divided by 2, plus the summation of the remaining areas between a1 and an. Between the first and the last section, whatever the area is, just add it up. You can write like this, or you can write like this. D by 2, take out 2 outside. It's areas of the first and the last section plus twice the summation of the remaining section. You can have the tabular form also. Get the changes. Note on the depths of the different sections. Get the areas of the middle and the side areas. After that, you take the mean area. Take the area of the first one, area of the second one, average it, put it in the next mean area column. Earlier, we used to do it for the depth itself, but in this method, we are going to get the areas. Put it in the first, take the area of the first section and the area of the second section, average it, put it in the mean area column in the second section. Now last one is the Priss model formula. Making use of this Priss model formula, we are going to get the volume. And the volume is given by the formula L by 6, only if it is between two sections, A1 plus A2 plus 4 times of AM. Let us understand how to get the A1, A2 and AM. It's a combination of the first two methods, that is mid-sectional area method and the mean sectional area method. What does it mean? Let us understand it. A1 is the area of the first section and A2 is the area of the last section, that is the next section. These are the areas. But AM is not average of A1 and A2. It is by mid-sectional area method we are going to calculate, and that is you calculate the mean depth dm, that is average of d1 and d2. This is a mid-sectional area method, this is a mean sectional area method. So it's a combination of that we are going to get it. Be careful in putting the values here to get the value of quantities. If it is a multiple section, the Priss formula is written as d by 3 into a0 plus an. A0 I can write, or I can write a1 an. This is a2 a4 a6 like this. A0 it is the first designation I have taken. Subsequently I can use either a0 or a1 a2 a3 a4 like this. 4 times a1 plus a3 plus a5 plus 2 times of a1 plus a4 plus a4 a6 goes on. That is nothing but volume is equal to d by 3. D by 3 is the distance between the two sections into the summation of the areas of the first and the last area, and the second one is an even odd section plus 4 times sum of the odd areas like this one, A1, A3, A5, plus twice the area of the even sections. So this is the Priss model formula. Let us try to understand how to calculate the volumes by making use of all these 3 formulas in the problems. And whenever you are using this Priss model formula, always the number of sections to be is odd in number. Now here I find 1, 2, 3, 4. Now if it is even, I have to take only the odd numbers into consideration. The last part should be treated separately. This last part should be treated separately by method of mean section area method, that is trapezoidal method. You have to calculate the volume and add it to this formula. So I'll explain about all these things by taking a typical example, and will make you understand what does it mean. Always this method is adopted for odd number of strips or cross sections. We'll make you understand this by taking 2 examples. And let me take the first problem. You have to calculate the quantity of earthwork for a road which has got a 200 meters length and the banks having a depth of 1 meter at the front side and 1.5 meters at the other section, having a formation width of 10 meters with a side slope of 2:1. Now y vertical slope is 1, therefore S is equal to 2. There is no transverse slope, that means it is flat. On flat ground we are going to estimate. So write down the given data like this. The formation width is 10 meters, the depth at section 1 is 1, D1 1 meter, D2 is 1.5, side slope S is 2. So let me go with the first method, midsection formula method. So the quantity is given by AM into L. AM is nothing but BDM plus SDM square. Get the mean depth, that is D1 plus D2 by 2. Get the average depth of that. Multiply by that by the length. So mean depth is known. Get the area. Multiply that by the length. You will get the quantity. It is 3125 meter cube. And let us take the second method, the same problem. We are solving it by second method, the mean sectional area method. First get the area of the first section, A1 is BD1 plus SD1 square. Get the area of the second section, it is BD2 plus SD square. Get the mean area of that is A1 plus A2 by 2. Multiply that by the length. You'll get the quantity equal to 3150 meter cube. It has increased a little bit. Let us understand the third method of solving the problem by Priss model formula. Now the quantity of earthwork for this trapezoidal shape is given by the formula L by 6 into A1 plus A2 plus 4 times of AM, where A1 and A2 are the areas of the cross section at the first section and the last section, which is calculated by the formula BD1 plus SD1 square. A2 is the area of the second section, which is given by BD2 plus SD2 square, whereas AM is not the area of the average of A1 and A2. It is to be calculated by the mid-sectional area method, that is we have to take the mean depth DM, which is equal to D1 plus D2 by 2, the mean depth of that. For this you find out the mean area. For this mean depth, you find out the mean area, then substitute in this formula, get the final quantity. It is 3133.33 mm cube. Now we can have a look on all the three methods, the volume that has been calculated. By midsection area method, we got 3125 meter cube. By mean section area method, 3150 meter cube. And by the Priss model formula, 3133.33 meter cube. Almost all of them are very close to each other. The percentage of error, if at all you want to call, is hardly 0.2, 0.3%. It is less than even 0.5% among themselves. Therefore, there is no need to worry about the quantity that we have estimated by different methods. Now let us take another problem where a multiple section has been given here, where the railway embankment has got a formation width of 10 meters at the top with a side slope of 1.5:1, where S is equal to 1.5. The total length of the embankment is 120 meters, where the depths are being taken at interval of 20 meters. So it is a multiple section problem. We can adopt any method. Either we can solve it by formula, making use of the formula, or by the tabular column. Now this is the typical isometric view of the section. Let us mark the depths, 2.2, 3.7 like this, 2.2, 3.7, 3.8 at different intervals of 20 meters, equal intervals. So capital B is 10 meter, the formation width, side slope 1.5 and horizontal slope is 1.5. In general, we have got the formula to calculate the area of the trapezium as BD plus SD square. Let us find out the cross-sectional areas of each sections. A1 using the BD1 plus SD1 square, like that. A2, A3, A4 for the different depths. You can find only the depths are varying. And this is an odd number of section problem. 1, 2, 3, 4, 5, 6, 7 sections are there. So we can apply the Priss model formula and solve it by whatever the formula we have given it there. Trapezoidal formula is given by the formula d by 2 into A1 area of the first one and plus area of the last section plus twice the area of the remaining section between the first and the last section. Substitute, and the final product of the volume was 36258.9 meter cube, 6258.9, that is 6259 or 60 you can call. Then get the value of volume by Priss model formula, d by 3 into A1 plus A7 plus 4 times of this A2, A4 and A6 plus twice A3 and A5. Substitute in all the values of the areas calculated. The quantity is 6316.5 meter cube. Now let us take another problem where the number of sections will be even in nature. 1, 2, 3, 4, 5, 6. I'll calculate this volume by using Priss model formula. The formation of the road embankment is 8 meters. The side slopes are 2:1, therefore S is equal to 2. The length of between the first and the last section is 300 meters. We got the depths, and it's an even number of section. Let us try to understand how to solve it. Area as usual, BD plus SD square. The last part of the section is treated separately. Let us understand that. I'll calculate the area of each section. Yes. Volume is given by d by 3 into A1 plus the last section is A5 I am going to take, plus twice the areas of the odd number of sections, that is A2 and A4, twice the area of the even section. I am talking only between A1 and A5. The last part between A5 and A6 is treated separately, and we are going to calculate that by mean sectional area method, where it is the average area of the last two sections, that is 12.1 and the 6.2.26 will be taken, the average of that, multiply that by the width of the section between them, you will get the volume, that is 459 meter cube. Add this is the last part of the section to this formula, get the final volume by the Priss model formula. This is how we have to calculate if it is an even number of sections. Treating the last part separately, taking the area by mean sectional area method and adding it to the Priss model formula between the first and the last but one section. Let's take another problem where there is a longitudinal slope of upgrade 1 in 100. There is a rising gradient. For the multiple sections you have to solve. Let us try to get the results from trapezoidal and Priss model formulas. This is the ground level, and the formation level at the first point is given as 102.5. Let us try to understand this with graphical representation also, that is by drawing the longitudinal section in this problem. I got the formation width as say 8 meters, side slope of the embankment equal to 2, and it is a rising gradient. The road is sloping longitudinally in a gradient of 1 in 100 meters, but we have got the sections at every 20 meters. Therefore, calculate what should be the height to be added for the rise in the ground level or formation level with respect to the previous section by considering it. So this is a rising gradient. For every 100 meters we have got a 1 meter rise. For every 20 meters, what is the rise? So this will calculate and make use of it in calculating the new formation level. So y to be added at every section is 0.2 meter with respect to the previous formation level to get the next new formation level. We'll show you this one by one in the calculation. As an example, if I want to know the chainage at the formation 20 meters chainage, the formation level here, we should add to this formation level at 0 chainage by an amount equal to 0.2 meters. And continue this till the end. Let us understand that. By making use of a tabular column, there is a tabular column I have generated. There is the distances, ground level, the formation level. The difference between the formation level and the ground level will give you the depth of the sections, get the central area, get the side area, and the total area of that will designate it by the notations A1, A2, A3 like this, and understand it. I will just draw a longitudinal section of this to make you understand, and not necessary to be drawn in the examination. It's only to make you understand the concept. I got the distance, ground level and formation level rows. I'll enter the values of the distances in the distance row columns 0 to 120 meters, enter all the given data of the ground level. Also enter it here at the top in the drawing part. Without drawing this, you can calculate this. Absolutely, there is no problem. Only to understand the concept, I am just going with this. Let us assume the datum, the lowest of this one, any value, to mark the vertical ordinates. Already all these things you have studied in your surveying. I am going to plot this to a scale of horizontal scale equal to 1:1000, 1 centimeter for every 1000 centimeters, that is 1 centimeter equal to for 10 meters. A vertical scale of 1:100, 10 times greater. I'll mark the first point. 101.5 minus 100 will get me 1.5. I'll mark it to a scale of 1:100, get like this. So we're going to mark all the vertical ordinates of the ground level. This is the profile of the ground level. Join them by straight lines. This is the given profile of the ground level. Along with this, he has given you the formation level of the zero chainage, 102.5. We'll mark it here, and we'll mark it above this ground level at zero chainage. The next formation level, you're going to get it is previous formation level plus 0.2 meters. The slope was 1/100. For every 20 meters, you are going to add it by 0.2, 102.6. Right here, plot it here. Similarly, calculate for other chainages. It is 102.9. Each time we are adding 0.2. Like this, you calculate all the values, plot it over here. So these are the points of the formation level above each chainage. Join them. This is a road formation level. Remaining things we'll calculate. The depth of between these two is nothing but, at each chainage, it is nothing but the difference of formation level and the ground level. These are the depths. So that is FL minus ground level, 1 meter for the zero chainage, 1.6. Calculate like this. The difference is FL minus GL. So now you know the depths of each section. Once you know it, put it in the formula central area section as well as in the side section. Get me the total areas. This is B into D. B is 8 meter. 8 into 1, 8 meter. 8 into 1.6, 12.8. 8 into 1, 8, 8, 7.2, like this goes. SD square, the slope is 2. 2 into 1 square is 2. 2 into 1.6 square is 5.12. Like this, it goes on. Get the side areas. Add this to summation of this. 8 plus 2 is 10. 12.8 plus 5.12 is 7. Like this, you'll get the total areas. Add up all these things. So get the areas. I'll designate this with A1, A2, A3, A4, A5, A6 like this. And here I find it odd number of section. 1, 2, 3, 4, 5, 6, 7. So I can apply the formula directly for the Priss model formula. The same tabular column has been regenerated here. Now apply the trapezoidal formula. You are used to this formula now. A1 plus AN plus twice the summation of the remaining areas. The areas are here. Substitute in the formula, get the total area. It is 1243.2 meter cube. Similarly, get the volume of earthwork for the Priss model formula. Substitute the values. of A1 to A7 in the appropriate positions. The volume is 1288.26 meter cube. We don't find much difference here, marginal difference. Okay, now let us go to the last part of this session, where we are going to study about how to get the volume of or the capacity of water that can be stored in the reservoir. Now here you find a typical view where this is the bund, where I am going to construct a bund across the stream, and we want to find out the capacity of this tank or the reservoir. So we are going to find out the contours by indirect method in the field. You know the contours, these are the contours. That is, the difference between these two contours will be the contour interval. And these things you would have studied in your survey camp, extensive survey camp. These are the contours. Now let us find out how to calculate the volume of a reservoir using these contours. This is what I have written, a typical drawing. I have drawn it for one of the survey station where we were working in very close to Bangalore, around 53 kilometers from Bangalore, near Doddaballapur, called as Sri Ghati Subramanya site, work site. Or if it is a depression like this, the inner contours will tell me that it is the lower portion, and this is at the higher level. I have taken a section and plotted the cross section. I want to find out the water impounded in this pond. So we are going to make use of the contours, find out the volume that is stored in this pond by this method, contour method. I'll take a typical example. The contours are here, 101, 102, 3, 4 like this. And it's odd number, 1, 2, 3, 4 up to 9, odd number of sections. For each area bounded by the contour has been given here. All these areas can be calculated or found out from using a planimeter. You can find out the areas. Now here right now it has been given. We will make use of this, apply it in the formula. The contour is nothing but the differences between these two. Put it in the trapezoidal formula, get the volume. Similarly, you can also solve it by Priss model formula. D3, D is nothing but the contour interval I said, difference between these two. If at all, if there is any variation, differences, we'll try to solve that in the coming sessions. Hope you understood how to calculate the volume by Priss model and trapezoidal when there is cross section, there is no transverse slope. In the next session, we'll try to do problems, some more problems on no transitional areas at the same time. We'll also learn how to calculate the volume of earthwork in a hilly area when it is partially in cutting, partially in embankment, or fully in cutting or fully in embankment. All these things in the next session. If you like this video, kindly comment on that and do subscribe. Those of you not subscribed, do subscribe for our YouTube channel. Thank you for watching.